My name's Isaac, and this is my project demo for SIT 210. So I've started to do my project on the Internet of Things, the movement where you're able to connect seamlessly unrelated devices and have them all working on the same network that the user would be able to control wirelessly or just have it passively going in the background without any interaction at all. So for this project, I've decided to start all this stuff off with a automatic blind system, a motorized blind system. So I guess we'll start off with the code. Here we are at the right at the top. It's just your basic import statements. You got your GPI 0 for your mapping, time and date time. But there's also Takinta there, which is what I've decided to use to design and make my interface with all the buttons and bits and bobs that the user can interact with to actually get the motor going. I've decided to use Takinta just because it's what I've used before, it's what I'm familiar with. There's no other reason other than that. Underneath that, we have pin allocation. So with the DC motor that I'm using, all you need to get this thing going is a direction and a speed. So backwards comes out of the GPIO pin 18, forward comes out of 23, and we get the actual speed of the motor from GPIO 24. Underneath that, we have just a few Takinta statements just to get the window open, give that window a title, just blind interface. Then we have that's just the font. There's nothing special about that. I could make it any font you want, any size, any color, whatever. Okay, so underneath this, we have some variables. Now, length 5 comes, as you see in all the next definitions, length is just the length of time that the motor is going for. Obviously, not every window is the same length, and you'll have to reconfigure this hard coded into the code. Obviously, I'd like a better way around that, as not everyone is going to be able to have that kind of knowledge. Not everyone else in the world studies computer science. But I've also just set it to 5 just for testing purposes. I could set it to 30 seconds or 25, but 5 seconds just gives me like quick prototyping time, just so I can see if new things work. Above that, we have now is equal to datetime.datetime now. That's just saying that the variable now is equal to the time right now. Under that, the last two variables is for x and for y. This is just getting two random numbers between 5 and 9, and another one between 18 and 21. Just one number between each ranges. So we also have our first profile, our first definition, which is def time. This is just saying if the time is between 7 and 19, backwards equals on. So this, if the blind is facing on the outside of the roll, it'll roll it up because you want it up during the sun and down during nighttime. So anything else that isn't daytime, that isn't between 7 and 19, it goes down. You got the speed flag, which is just 500, and then just a calculation, speed flag divided by 1,000. It sleeps for the length time, which we talked about above. That can be changed whenever. 5 is just the prototyping purpose. And after that time, speed is equal to 0, so it stops moving. Now, with our second definition away, you get to see why we had those random numbers up at the top. So, works the same as time, where if date time is between this time and that time, it should be up. Anything else should be closed. So, but for this one, it's based around being away on holiday. You don't want people seeing that nobody's home or that the blinds are always shut. People might think you're not at home and they might come in and steal your stuff. You never know. But with this one, it randomly picks a time between, I think, 7 and 9 is what I set it to. I'm not quite sure, I can't remember. And the same with the afternoon between 7 and 10, a random hour will be picked, and that's when it closes. And it'll keep doing that until you turn it off and pick another profile, whether it be time or just your custom. So yeah, I won't go through it away with you because it's the exact same as time. But then we have custom up and custom down. These are just pretty much the exact same, but also opposites. So with custom up, when you press a button, backwards will turn on, it'll set a speed, and it will roll up. At least it will roll up if the blind is on the backside, window side of the roll. And if you want it to go down, you click the other one, sets the speed, takes it down, and then sets it to 0. And with this last little bit of code just underneath the widgets, that's just for Takinta. You've got your button for each profile. Time button, away button, up and down.
Okay, so before I demo the actual hardware and give you the tour of that, I want to actually clarify what I mean by the blind being on the back side. So with this blind here, if it were to go down, it goes down like that. And you pull anti-clockwise and it goes up. So with the DC motor, forward is clockwise, back is anti-clockwise. If you had your blind on the other side of that, it would be the other way around, which would be a bit of an issue when you went to press down and it went up, and if you pressed up, it went down. Then you'd have it clocking around and you might break it, which you don't want at all. Hardware, got the Raspberry Pi B. I've used the Raspberry Pi just because I've heard that it's better for web development, which could be a phase of how I use the interface and get it user controlled. And I also just like working with it, just personal preference. I like coding in Python. It's just my most used code, I guess. I've got more time into that one. I know the stuff better. But really I could have used the particle photon or even the Arduino as well. This is what I use to control my motor, my DC motor here. It's a single motor driver. I could have got a driver that sat on top of the Raspberry Pi, but I felt like that was a bit overkill. I only want to control the one motor, and those things are built to control sometimes 4, and that was just a bit unnecessary for what I was doing. This is the battery pack. This is just 4 AA's. I think it measures to about 6 volts. This powers the DC motor. It's just plugged in on this side, although I do need another power source for this, but I've got a battery pack right here that will just do the job. There it is, measurement. I think I might have more in the back. Yep, here we go. So yeah, that's what I was planning to use to power my Pi, although it isn't very charged at the moment. That's okay. Over here are some headers for the motor. I was a bit worried when I first opened this. I thought the blue threw me off a bit, thought it was plastic, but it is metal. It'll do well for spinning, attaching it to the blind and spinning it both ways. It'll cover more area, it'll make it spin easier, rather than just connecting this tiny tip that spins. So this is the screen I was talking about before. It's a 2.8 inch touch screen that I'd be able to fit the interface on. That will actually control the blind. From the photo there, you can see that it sits on top of the Raspberry Pi, much like the more technical motor controllers, motor drivers that we've seen. What I was a bit worried about and why I didn't do this now was because I didn't know how it would fit with the pins going into the GPIO. It looks like it covers it up a bit, and it's something that I'd rather do maybe once I've got a PCB on top of the Raspberry Pi. That way it'd be a lot neater. You wouldn't have wires sitting everywhere to make it a lot easier to mount. That's another reason why I didn't really want to mount it, because there's so many different intricate parts. I'd have to attach the Raspberry Pi to the wall, the breadboard, the battery pack, and then find a way to attach the motor not only just to the blind, but to the wall. Yeah, it's definitely something that I'd rather look into later on, say with our extended unit next year, where we start doing stuff like PCBs and soldering and whatnot.